let's say define each of the following terms. So moment of a force. So what I have for this one is the definition. So the moment of a force is the product of the force and the perpendicular distance to the pivot. Mhm. Um, put that in red so you see better. So, right. So that is just one mark there. Now, what I have for the formula, I have M for moment, capital M. The unit for that is Newton meters. So I put in the unit in bracket is equal to force. The unit for force is newtons multiplied by the distance, which is d, and the unit is meters. So M is equal to moment. F is equal to force, and d is equal to distance. Now this is 3 marks, so I don't think they will just give you 3 marks for just put in a sentence. That's why I say steady format, like what you did and stuff, right? Now center of gravity. So this is just 2 marks, so a sentence go work for this one. So for this one, I have the center of gravity of an object is the point at which the weight of the object appears to act. Right? So that is the center of gravity. Part B state the two conditions necessary for a body to be in equilibrium. So what I had for this one is when an object is in equilibrium, it is not accelerating or rotating. The two equilibrium conditions are, so the first one, there is no resultant force acting on the object, or the net force is zero. The other one is the clockwise moment is equal to the anti-clockwise moment. Now there's different cases for this, right? So I would say the sum of the clockwise moment is equal to the sum of the anti-clockwise moments. For example, for the first law as well, there's another case, so that you could say that the total upward forces will be equal to total downward forces. I mean, you don't need to put all of this to get that 2 marks, but I come like I do a little review of the conditions there one time. So you understand it, right? So that is the definitions and stuff. Now, part C here, just a figure 2 shown below is a diagram of non-uniform wooden plank, which means that it is not constant. It varies. AB, which is 2 meters long. So if you start from A, let's say here is 0 meters, and then B will be 2 meters, and weighs 1000 newtons. So you have the weight here of the plank, which is 1000 newtons, right? Um, the plank is supported from a ceiling by two vertical springs, P and Q. The plank is attached at a distance of 0.5 meters from each end. So this is the ceiling, and P and Q, those are the two springs. C is the center of gravity as shown in figure 2. So that's the center of gravity of the plank. But remember, it's not uniform. If it was uniform, the center of gravity should have been like in the middle of it. And if the force for P and Q are the same values as well, it should have been in the middle. But P and Q are different values, right? And we will see soon. Now they say when the plank is horizontal, which means flat, the tension in the spring is 600 newtons. Calculate the tension in the spring Q and show all working. How are we going about this now? Well, um, the spring P and Q are supporting the plank, so therefore these are considered as upward forces. So I'm putting a straight line and an arrow upward at P and at Q here, right? Um, we have one downward force which is W. So we say total upward force is equal to total downward force. Or we can say that the sum of the upward force, Fu for upward force, is equal to the sum of the downward force. That E looking symbol of that is basic. That just means sum. This means the sum, right? So the upward forces are P and Q. So we know P is 600. So it will be P plus Q is equal to W. W is the downward force. And we just put in the values now. Remember, we know that P is equal to 600. We know W is equal to 1000. We do not know Q. We're trying to solve for Q. So replacing P with 600, we have 600 plus Q is equal to 1000, which is W. Carry across the 600, you're going to get Q to be equal to 1000 minus 600. So therefore, Q would be equal to 400 Newton. So that is the force of spring Q, 400, and P was 600. Now P and Q are different forces, and the plank is not uniform. Hence, the center of gravity is not in the middle of the plank. Right? Next part, by taking moments about A, determine the horizontal distance from P to C. Where is P to C now? P to C is this distance here that I'm going to put in green. This is the distance P to C. We have to find this distance. So I'm going to put as X, since that is an unknown. Now the distance P to Q. What do you think will be the distance from P to Q? Alright. Well, we have O to P is 0.5, and we have, well, Q to B is 0.5. Where is 0.5 plus 0.5? 1. But the total length of this plank from A to B is 2 meters. Look, I put it there, 2 meters. So 2 minus 1 will give me 1. Understand, right? So that is basically the distance from P to Q. So that is 1 meter. Understand, right? Right. So I have 1 meter is the distance from P to Q. I have X is the distance from P to C. So now I'm going to use that there to solve for the unknown length, which is X. So let me just flip this screen here. So how do I show the diagram when I'm doing this? Right? So we're going to take moments about A, which means I'm going to circle this point A here, right? A circle in point A, and every force is bending towards A now. So if P is bending towards A, it will look something like this. If Q is bending towards A, it will look something like this. If W is bending towards A, it will look something like this. So from this, what are my clockwise and anti-clockwise forces or moments? So you have to think about it like this. This is P, it going in this direction. That is anti-clockwise. Q will be bending, since that's upward and it bending towards A, this will be anti-clockwise as well. Anti-clockwise is this direction. Clockwise is this direction. Right? So W will be clockwise. So we have to say now the sum of the clockwise moment will be equal to the sum of the anti-clockwise moment. So from this here now, the clockwise moments will be W alone. So what is the formula for moment? What is moment? Moment is what? So moment is force multiplied by distance. So that's what you had to do for each case here, each force here. Multiply the force by the distance it is from A. So looking at W, it will be the force of W, which is 1000 multiply. How far is W from A? So to get the distance of W from A, remember is this 0.5 here that I have, and this X, which is the unknown that will give me the distance. W is from A. So that will be 0.5 plus X. This is the force multiplied by the distance. The distance is 0.5 plus X. The distance is written in terms of X. The force is 1000. So this is the only clockwise moment we have here. So you put your equal sign and now you're putting the anti-clockwise moments. Now how far is P from A? With the distance of P from A. Right, so P, looking at the diagram, P is a distance of 0.5. This is 0.5 there from A. So I'm going to say now it's force by distance, right? The force of P is 600 times the distance P is from A is 0.5 plus the force of Q, which is 400 times the distance it is from A. How far is Q from A? 1.5, because we might have to take into consideration this 1 meter here, which is the distance from P to Q, plus the 0.5, which is the distance from A to P. So the distance of A to P is 1, well, is 0.5, plus the distance from P to Q, which is 1. So 0.5 plus 1 is 1.5. So that is our for the 1.5 for the distance from A to Q. Now I had to multiply and do some algebra and make x the subject of the formula here. This is the principle of moments I apply here. Sum of clockwise moment is equal to sum of anti-clockwise moment. So you're going to have to expand out this. You're going to say 1000 by 0.5 and 1000 by x. Where's 1000 by 0.5? 500. And 1000 times x is 1000x. Now 600 by 0.5, that's basically half of 600, which is 300. Plus 400 by 1.5 is basically 600. So you have 1000 x. 1000x is equal 300 plus 600 is 900. So I combine the 300 and the 600, I get 900. But wait a minute, I the 500 here, but if I carry across the 500, it will become negative 500. So I now put 900 minus 500 on the right hand side. So I have 1000x is equal to 900 minus 500, which is 400. So x is therefore equal to 400 divided by 1000. So x is therefore equal 400 divided by 1000 is 0.4. What is the unit for this? It is meters. So the distance of x is 0.4 meters. But x represented the distance from P to C. So therefore the distance from P to C was x, and that is actually 0.4 meters. Understand this, right? Right. So that is that. The last part, this is state why the center of gravity is located to the point P than the point Q. So I'm gonna put the explanation here now. So since the Planck was not uniform and the forces at P and Q are different, for the Planck to be or to remain horizontal, the center of gravity should be or is closer to P. Right? So the weight of 1000 Newton must provide a clockwise moment to balance the total anti-clockwise moment. Yes, this can only happen if the center of gravity is closer to P. Right. So you understand the solution for this question, right?